This is lab 4 for physics 1, dealing with oscillation. The purpose of this lab was to observe a mass hanging on the end of a spring in free hanging. So the only forces acting upon it are gravity and the spring, and to observe how it moves and the forces acting upon it. Our principles of this experiment are the force of gravity and the spring force, which are the only two forces acting upon the mass. Then for the internal energy of the mass, we have the gravitational potential energy, the spring potential energy, and the kinetic energy. And then, of course, we have the basics, the velocity and position update. And what we're hoping to see, what we should see, is something kind of what we have in the middle, whereas if you imagine that top line as a spring, then your circle as the mass hanging on the end of it, we should have it oscillating, moving in a circular-like motion in both the x and y directions. So we observed this video of a mass being our system and everything else being the surroundings on the end of a spring, free hanging, only gravity and the spring acting upon it. And when we plotted its movement, when we plotted x and y separately against time, we got these nice waves indicating that it is moving in a circular movement, circular in x and circular in y, which then kind of ends up creating this diagonal shape, as you can see by the red on the actual video. So yeah, pretty neat. Then we set up a computer model to replicate this in a computer, put in our constants, the gravitational force, the spring constant, and the relaxed length of the spring, which I got from the pre-lecture video, the initial position and everything, and then put in our equations for the kinetic energy, gravitational potential energy, spring potential energy, and total energy. Then set up our while loop to calculate it in a loop. Then hit play and got these nice graphs. As you can see, how it turns out when it's moving is it sort of creates this nice box because the oval pattern that it moves in, rotates around, doesn't stay still. And so yeah, it creates that nice little box there. And for our energy graph here in the middle, what we see is that our delta E is staying nice and constant. Our energy principle is holding up. There is a conservation of energy when we have changes in either the spring gravitational energy or the spring potential energy or the gravitational potential energy. They both change to counteract each other. The kinetic energy is also changing to counteract that stuff. So yeah, delta E stays a nice constant 0, in line with conservation of energy. And since it's a model, there's no energy decay, which is shown in the real world, which, going back to the last slide, if you looked closely, you can see that the waves start to like flatten out just slightly. And you can even see that in these graphs with the red. The blue is very constant, that's our model. The red, which is what we observe, starts to decay. But they're pretty much right on top of each other. So what does it mean? For our model, is the energy principle satisfied? Well, that's what I was just talking about. That delta E is a nice flat 0. And what that means essentially is that as each individual component of the mass's internal energy, the kinetic energy, the spring potential energy, and the gravitational potential energy change, they all change in accordance in order to balance each other out so that delta E stays nice and constant. And then using the data you obtain in Tracker, make two separate estimates of oscillation periods. So from the x-axis, I got an oscillation period of about 2.1 seconds, and from the y-axis, I got an oscillation period of about 1.5 seconds. And what this represents is our starting position and velocity from that observation. So we can see that like the x, there was more difference from 0 in the x starting position than there was in the y, or at least for y, like where it would naturally balance out to, that approximately 0.7 meters. So as the spring exerted force it would pull over further for the X, whereas for Y there was less change, so the spring was less powerful in essence. Additionally, gravity helps cancel out that Y. Helps bring that Y back to the center, so without gravity canceling out the X can be a bit more varied, a bit wider with that 2.1 seconds against the 1.5. Thank you.